we now head to this guy over here. And this is really what I've kind of been building towards, because this is a slightly different thing. The one thing to notice is that all the equivalencies that served me so well with these two don't exist here. So I'm going to go through the solve of this a little bit more slowly just to kind of show you what I mean. And to those who have this puzzle, if you're wondering how to get through that last step, I'm going to show you. Anyway, I put this all on the same side, so we proceed the same way, but you're seeing a lot more variations with the colors, and not a whole lot, absolutely no translational or rotational equivalencies within the centers. So what we'll do is the same kind of thing. I've got these two greens. I've got a 1 by 1 by 2 bar here, so I'm going to find a yellow, an orange rather, with an orange and green. There goes that color blindness. So I've got two to choose from. Which one is the right one? You can see it's this one. So let's get an orange one to here. R-I-D-I-R-D, R-I-D-I-R-D. Okay, so it's this one. I just have to put an orange in here, right there. D-I-R-D, R-I-D-I-R-D. Okay, move this in, and we've got our 1 by 2 by 2 sheet. Move this in here and up. Now I just do the yellow flanked by an orange and a green. So here's a yellow. Now which one is it? Well, I can move this into here and find that it's not this guy. So it must be this guy. And it's a yellow edge that I'm looking at, so let's just turn this down. So I got some yellows to choose from. There's this. Move this here. And now we'll just move this up. And what I'm looking for is a yellow and green. Maybe this guy, is it? And it is. So I just have to turn this guy up, move this guy in, and now we just move him down. Counterclockwise rotation, which is one swing of this algorithm. Move this in, and bang. So far, so good. So far we're thinking, all right, it's a nice little addition to the collection, but so far, no difference. Now this is in, and now we move on to the next one. So now we're going to go for the next one, and let's see, we don't have anything lined up. See if there's something that I can easily do. Well, we can take this white one and move it into here. So we're going to do a counterclockwise rotation, which is just one. Commutator of R-I-D-A-R-D. Move it in. R-I-D-A-R-D it. And bring it out. So far, no problems. And now that I have this, I'm looking for the orange with the orange and white, and I know it's not this one because this is facing the wrong way here. So it's this one. Now I need to bring this up so I can move an orange one in here. So I've got this orange set up, and I'll move this one in. 1, 2, and now I bring it down. A quick counterclockwise rotation. 1, 2, and that brings that down. Now I'm going to take this guy, wheel it into here to make this 1 by 2 by 2 sheet, and bring it up, and bring it back. So far, no worries. So now we continue doing what we're doing. We've got this sheet over here. I'm looking for the yellow surrounded by yellow and white, and yellow and orange. Here's the yellow and white. Is it the right one? Moving it over here, it appears that it is. So that just means I need to take this yellow and go zoom. This is over here. Let's move this up. R, D, and splat. Now I need to find the yellow and orange for this, which is this guy here. I think that's the only one. Well, there's another one, but that's already spoken for, so we're good. So now we're going to take this, move this into here, and I'll move it to the bottom. D-I-R-D, and go 1, 2. So we're doing well. Now we just need to move this in. And I'm going to use that technique so that I don't destroy this. Move it in, like this, and move it one more. Hold it here and do a corner swap. To our U, to our UI, to R. To those who have this puzzle, this probably isn't the step that's been as much of an issue. So this is in and this is in. And now we get to the dreaded last two ones. Now you saw how easy it was for this guy and this guy. And to those who've experienced the true AI, you know that there's a little bit of a complication with that. This is even worse. Because the problem with this puzzle is that there's no equivalencies with these centers, and that was the issue. I could not solve this like this guy. It was much too hard. Couldn't solve it like the version 1. I couldn't even solve it like the AI puzzle. And believe me, I tried, and I do have a technique, a way that I do the last two 4x4, the last two 2x2 corners. But I couldn't do it this way because I relied upon the equivalencies of the centers in different 2x2 segments. I couldn't do that this time. So here's how I took to do this. What I did is first start off by creating 1x2 sheets on both sides. So I've got this already over here. Now we're going to find the green with the green and white, which is over here. Is this the right one? And we find that it is not. Yeah, actually it is. So I need to put a white one, rather a green one in here, which will be this. So I'm going to move this in here and simply move this down here. R-I-D-I-R-D, D-I-R-D. Move this here. And now turn this clockwise to come into here. A clockwise turn is doing the R-I-D-I-R-D commutator twice. R-D, R-I-D-I-R-D. Now that knowledge is going to become important. Move it in. I created the sheet. And now I move it out. D-I-R-D, and I move it back. Okay, now that I've created this sheet, I'm going to create another 1x2 sheet over here as well. So basically, this is the confirmation that I wanted. It turns out it's the same colors except for the bottom part, but that's okay. So we've got this 1x2 sheet and this 1x2 sheet. It was easy to get the first one. The next one just was a matter of a little bit of sorting around, so that's not too hard either. But now this is where we get stuck. This is where we come into a problem. The problem here is I have these three that are out, and I have to, well, basically coordinate a 3-cycle. Now in any other puzzle, that wouldn't be a problem, because what we talked about with the dreidel cube actually is how to coordinate a 3-cycle. In order to do a 3-cycle, you need to, well, get a commutator. A commutator is easy to generate. What a commutator is it consists of two parts. The first part is you do 2 moves, and then you undo those 2 moves, like R-I-D-I-R-D or U-R-U-I-R-I, something like that. That's the first part. The second part is some kind of a middle move. The middle move looks at the configuration that you had with the first part of the commutator and realize what pieces were taken out. You then look at what piece can be isolated within a movement of a layer, where it's the only piece that was taken out that will be moved. Everything else wouldn't be was not taken out, wasn't changed after you did the commutator. And then the third part is you undo the commutator. You do the reverse of it. So a commutator is 2 moves and then undoing the 2 moves. The second part is you do a middle move that isolates one of the pieces that were taken out, and then the second is you reverse the entire commutator, and then you reverse the middle move. So basically with that you end up with a 3-cycle. So it all starts off with doing a commutator and undoing the commutator. 2 moves, undoing the 2 moves, and then reversing the entire first part. So I just have to design something like that, but here's where I came into a problem. In addition, this puzzle is also bandaged. Evan, please shush. In addition, this puzzle is also bandaged, which means that I can't move those layers. Like let's say I do a commutator and I see that these are all out. This entire layer here is fine except for this, but I can't move this down because this is all bandaged over here. So I have no way of doing a middle move in order to isolate this. So that's where we get stuck with this. So designing the commutator is not difficult, but being able to enact it is. So because I can't do this move out over here, I have to do a surrogate move. Or this move out over here if this piece were isolated. So imagine doing a commutator and everything else was placed fine except for maybe these moves, this move, these pieces, and this piece. None of these pieces were taken out except this. So if I do a middle move that moves this down, then we'd be fine, but I can't do that. So what I have to do then is design a surrogate move where instead of moving it in this layer, I turn it and move it in this layer and then turn it back. So that was the challenge to this puzzle, designing a commutator and then designing a surrogate move for the middle move. And here's what I came up with. So anytime you have two sheets in, you're going to have a situation where you have one where you have everything in except one, and the other where you have everything except two. So what we're going to do is we're going to take this piece here, we're going to rotate it here so that this move that's out is here. So the one that has one piece out is on the right side, and the piece that's out is all the way to the right, and the one with two pieces out is on the left side. So this means that we're going to have to do a counterclockwise move to bring this here. R-I-D-I, R-D, R-I-D-I, R-D. Okay, so basically what I need to coordinate is a commutator. A commutator that moves this to here, and this to here. Okay, so I'm going to pick it up from here. Basically where we're at right now is I've got this in, I've got this in, and I need to get these two in. My strategy with this was to put the 1x2x2 plate here and here, and if I do that, I'm inevitably going to have one side where there's two centers out and one where there's one center out. And basically what I need to do is I need to just perform a 3-cycle. This to here, and this to here. Now I kind of rearranged it a little bit because I don't want to put it in the first time. I just kind of want to demonstrate what I'm going to do, because in reality this has to come here, this has to come here, and this has to come here. So how do I do a 3-cycle? Well, the concept of doing a 3-cycle enters into what a commutator is. So a commutator is a series of moves where basically you do 2 moves and then you undo those 2 moves. So that's 4 moves to start off with. So that's something like R, U, R, I, U, I, or R, D, R, I, D, I, R, I, U, R, U, I. So basically 2 moves and then you undo the 2 moves. What you're going to find is that when you do that, you end up with a configuration where all except a couple are still in. So a couple pieces are going to be out. You take a look at one of the pieces that's out, and then you find the plane in which it's the only one that's out. So then you do a middle move, and that middle move takes the area that something is out, then you move it through that plane, and then you do the reverse of the commutator that you did at the beginning. So if you did R, U, R, I, U, I, then you do UI, RI, UR, or something like that. And then you redo the middle move from there. So basically, if you do that, you're going to end up with a 3-cycle, and that's all I have to design here. So if I were to demonstrate that, let's see, is there another puzzle around here that I can maybe demonstrate that on? Another puzzle, yeah, how about this one? So I'm going to demonstrate what I mean. I already demonstrated that with the dreidel cube. If you want to go back when we were talking about how to design commutators, I did that here. This is a master face turning octahedron. Very cool puzzle by Tom Z. But in any case, in order to solve this, there's some reduction that has to happen with these guys and these guys, but inevitably you're going to deal with a situation where you have to do a 3-cycle. Designing a 3-cycle is easy. Just go ahead and pick any type of 2 moves and then undo those 2 moves. So it can be anything, something easy to identify. We'll call it this move over here and this move over here. Now this is completely by random. You can do any set of move that you want, but this is how you'd do that to start off with a puzzle like this. We'll do a R, U, R, I, U, I. Just like that. Now we take a look. That's half of the commutator is done. We see that all of this is still in place. This is all still fine. We take a look at what's been taken out. This is all in, taken out, taken out, taken out. I look around and I find which piece that was taken out can be isolated. And this one sticks out like a sore thumb. So this is taken out, but all the rest in this layer is in. And that's exactly what I'm looking for. Now that I've identified that, this was supposed to be a white. Well, this white ended up here, and this pink ended up here. So what I'm going to do with this layer is I'm going to make a move. It could be this move, or it could be this move. It doesn't really matter. It's any move within this layer where there's only one that I can isolate that I take out. So that's my middle move of my commutator. So what I'm going to do is I'm just going to move it down here like this. What this does is it puts the green one in where this pink one is. So the prediction is that the 3-cycle is going to cycle the green to the pink to the white. Those are what's going to cycle around. So I do my middle move like this, and now I reverse the original commutator, which was R, U, R, I, U, I. So now I'm going to do U, R, U, I, R, I, and then I take that middle move, and then I undo that original middle move, so I'll bring it back like so. And indeed, that's exactly what happened. Just doing that commutator with that exact structure gave me a 3 cycle. As predicted, this green, well, went to here, this pink went to here, and this white went to here. So now I know that when I run into trouble with the reduction of the last couple of edges here, if I can't seem to do it intuitively or just by placement, then I can always rely upon a 3 cycle to move this to here, and this to here. So I can take that 3 cycle and actually put all of these in just by positioning and repositioning. So let's do the same thing. RU, RI, UI. This isolates this here. Bring this down and undo it. Turn, 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 turn. Bring this back, and one more should do it. Turn, 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 turn. Bring this up. Turn, 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 and bring this back. So that takes a relatively complicated and somewhat difficult puzzle like this and it tames it. And that's what I do for any puzzle that I have that can have predictable movements like that, is I design 3 cycles. So in looking at this, that's what I wanted to do, is see if I can't design a 3 cycle with these. Well, there's a problem with this. Because if I were to start off with a commutator, well actually that's what I'll do, is I'll start off with a commutator. What that's going to be is I have to say rotate this clockwise. Now how do I do that? Well, I'm going to do a commutator to rotate this clockwise. That's my RIDIRD. It'll rotate this without affecting any of these guys. It'll affect these guys, but who cares? That doesn't really participate with the areas that we're actually dealing with right now. So let's go ahead and begin a commutator and see what we can do, because I want to cause a 3 cycle of these guys. So what I'm going to design is this will go clockwise, U, counterclockwise, UI. So what I'm going to do to move this clockwise is I have to do the RIDIRD commutator twice to bring it in. So I have commutators inside of commutators, basically. So we'll move this clockwise, so that's RIDIRD, RIDIRD, and again, RIDIRD, RIDIRD. So this yellow one is now down, it was up here. So that's my clockwise. I'll do a U. Now this will turn counterclockwise, and then a UI. To do counterclockwise, it's RIDIRD just once. RIDIRD, RIDIRD, and then take this back to a UI. So that's the first part of my commutator has been done. The second part is to do a middle move. And it's a middle move where I find a place I can isolate. Well, first let's see everything that's been taken out and everything that's the same. You can see these two 2x2x2 blocks are the same. With this whole 1x2x2 block, this sheet is the same. This didn't change. Over here, well, everything changed except for this. This corner was the same, and this edge is the same as well. So what can be isolated here? What was taken out? All of these were, well, this, and if I look at this layer here, this piece is isolated. So I can isolate this piece. If this weren't bandaged, what I can do is I can take this, just like I did with one of the layers here, is I can take a layer here, and I can move this down or move this up, and that would be fine. That would be my middle move. I would simply undo the commutator that I did, just do the opposite, and then put the middle move back, and it'll be done. But I can't because we're bandaged here. So what do I do? Well, that was the big dilemma with this puzzle. So what I decided to do is what I did with some of the Siamese puzzles, which is to do a surrogate move. I'd like to move this layer here, but I can't here. So what I'm going to do is turn this clockwise so that I can put this to here and then move this layer this way. Now it's not going to be a clean move because I'm going to be moving other things, but I'm going to take this, move it here, and replace it with this. This is the very piece that I wanted 3-cycled. So basically what I'm going to do is turn this clockwise, and then I can make my middle move but put it across over here. So I'm going to take this and move it clockwise. I'm going to move it clockwise. So that's RIDIRD, RIDIRD, and again DRIDIRD. All right. So what you find is that this turned clockwise, So this green is down. It's this move. This is going to be the piece that I'm isolating. And I'm going to do a D move, DI move with this, which will replace it with this piece over here. So now I just go, boom, DI. I'm sticking with the structure of my commutator exactly. Now that I've done that, I'm going to want to take this, and now I got to move this back up to here. Do another counterclockwise rotation, so that I can take this, all of this, and move this back up to here, including this over here, because you know, I'm trying to isolate that move. Now that I've isolated it, this has to be protected back. I have to bring it back up. So another counterclockwise maneuver, RI, DI, R, D, RI, DI, R, D. Okay, now that I've done that, I've completed my middle move, sort of. Now I'm just going to reverse the commutator. To reverse the commutator, instead of doing clockwise U, counterclockwise UI, I'm now going to go U, clockwise, UI, counterclockwise. And hope that works. So here's my U. Now I'm going to do clockwise. The orange will come down to here, so that's 2 turns of the commutator within a commutator. RI, DI, R, D, RI, DI, R, D. Whoop. RI, DI, R, D, RI, DI, R, D. Now I do a UI, which brings us back to here. So now I'm going to finish with my middle move. My middle move, I move this in with a DI, so now I'm going to move this back with a D, like so. Okay, so basically this gets that back in. These are all fine. Now I'm done with my commutator. However, when I did my middle move, it wasn't exactly a clean middle move because I was moving other pieces with it. My goal now is to undo some of those moves that caused that to go out of place. Everything that was supposed to move with the commutator did, and everything that was supposed to stay the same also stayed the same, but I reoriented it a little bit. So now what I'm going to do is I have to get things back. So although this is where it was, this top part was, these have sort of been swapped. I kind of swapped areas from here to here. So to get it back, I'm going to take this orange, bring it back to here, and then rotate it to the green to bring it back to here. So I'm going to move this back to here so that this is where it needs to be. Now I'm going to do a counterclockwise, rather a clockwise rotation to bring this green in conjunction with this. It's RI, DI, R, D, RI, DI, R, D, and again RI, DI, R, D, RI, DI, R, D. Now I'm going to move this back, which puts them back in line. Now having done that, I've pretty much finished the commutator. Things have been 3 cycled, they're just oriented wrong right now. So I need to take this, bring this back up to here so that this can once again be on the left side, and these two can be here. So both of these get a counterclockwise rotation. RI, DI, R, D, RI, DI, R, D. Same thing here, RI, DI, R, D, a counterclockwise rotation. So both of these had to move counterclockwise. So we find that at the end of that, that's actually what happened. I did do a 3 cycle. What was here went to here, this went to here, and this went to here. Now remember, to do the actual 3 cycle to solve it, this had to come here, this had to come here, this had to come here. That's not actually how I worked it out. But what I wanted to do was go through the process step by step to understand the reasoning of how that was done. That I actually held exactly to the form of the commutator, but I had to undo some steps afterwards because it wasn't completely a full, pure commutator the way that you saw with this. And that was because of the bandaging and the surrogate moves that I had to do. But at the end of the day, it did cause a 3 cycle of these 3. So now one more turn of this algorithm, this will come to here and be in, this will come to here and be in, and this will come to here and be in. However, although I went through step by step how the commutator was done, it still was a little kind of cumbersome to do. So what I did is I'm going to turn this into what I call, into what's called an algorithm. The difference between a commutator and an algorithm is a commutator is the basic form that you can use to move 3 pieces around. An algorithm is a set of instructions that are more complex that will cause a specific movement of pieces around the puzzle. So an algorithm is oftentimes made up of a bunch of different commutators. But what I did is notice some of the moves that I did was a little extraneous. For instance, you saw me do a DI, then you saw me do you saw me do a D, and then you saw me do a UI. Well, that's the same as not moving anything, but just rotating the puzzle this way. And rather than rotating the puzzle this way and working on the left side, why not keep it the same and just, rather working on the right side, why not just keep it the same and work on the left side? So what an algorithm does is it trims the fat of the movements that I did when I held to the form of the commutator and fixed things up. So all that means, all an algorithm is I took all the other motions that I did in the setups and whatnot of the commutator and put it all down into a recipe that will always work every time if I just hold to that. So I no longer memorize the commutator, I memorize the algorithm which trims the commutator down, and sometimes combines a few together to do more complex motions. So with that, I'm now going to take everything that I did, trim it down so that I don't do excess motions or do a D and then a UI and then operate on this side but keep it here and operate on this side, to come up with a 3-cycle that I came up with this specific puzzle which I've only been able to use for this specific puzzle. And it goes like this. And this is what you need to know if you have this puzzle and you need help with it. Start off on the right side, and with the right side with one center that's out being on the right side, and on the left side the 2 centers that are out being over here, of course. Go ahead and do counterclockwise, and I'll just describe what I'm going to do. It's going to be clockwise U, counterclockwise UI. Then you go to the left side and do the same thing, clockwise UI, counterclockwise U. Then you're going to do clockwise UI, clockwise U, and then you'll be done. So let's see how that works. Starting off on the right side, clockwise, R-I-D-I-R-D, R-I-D-I-R-D, got to do it twice, R-D, R-I-D-I-R-D, that was clockwise. Now we do a U, then do a counterclockwise on the left, R-I-D-I-R-D, R-I-D-I-R-D, and then do a UI. Now you'll recognize that that was just the first part of the commutator. Now we do the same thing, but on the left side, exactly the opposite. So we're going to do clockwise on the left, R-I-D-I-R-D, R-I-D-I-R-D, and again, R-I-D-I-R-D, R-I-D-I-R-D. Do a UI, then do a clockwise, or counterclockwise rather, R-I-D-I-R-D, R-I-D-I-R-D, and then move it back with a UI. Now you'll recognize that that's a combination of the middle move and the other algorithm. Rather the middle move and the other part of the commutator. Now what I'm going to do is I'm going to do a clockwise rotation here, do a U, I, and then a clockwise rotation again, and then a U. So pretty simple to remember. Clockwise, R-I-D-I-R-D, 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 R-I-D-I-R-D. Do a UI, and then do another clockwise rotation here, R-I-D-I-R-D, 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 and then do a UI, and you're done. You did it. So this is an algorithm which is a combination of a commutator as well as some fix-up moves that have been blended together and trimmed down to cause a 3-cycle. And that's how I 3-cycled this puzzle. This went to here, this went to here, and this went to here. The first time I went through the commutator in its strictest form just to demonstrate how I did it. Then I trimmed it down and showed you the algorithm, which shows you exactly how I come up with these things and how I was able to solve this problem. And I was able to do that by modifying the commutator concept to match with the bandaging of this puzzle so that I can do a surrogate move. So then it's just a matter of, well, solving the doggone thing. Now that you have put all of these in position, bring this over here, well actually over there we go. And now we do the top part, these two are in, we need to corner swap these. To R, U, to R, UI, to R, turn the puzzle, to R, UI, to R, U, to R. And bring this back. You see that this is in. On the top, we can maybe more quickly do this by bringing this to the side. R-I-D-I-R-D, R-I-D-I-R-D, and again, D, R-I-D-I-R-D, D. That's a shortcut on how to do this on a Megamorphix, and it's done. So version 2, among the hardest of the AI Megamorphix, actually let's not kid ourselves, the hardest of the AI Megamorphix, and might I say, one of the harder puzzles, believe it or not, that you can have is solved. And the reason why I wanted to bring this out is to those that have this puzzle that had a hard time, that's how I do it. But I also wanted to demonstrate how just a simple variation in the structure of these puzzles turn this into a puzzle to be reckoned with, among the harder puzzles from a bandit standpoint that you can do, in which you had to use all of your knowledge about how commutators work and how to modify it with circuit moves to make it happen. So hopefully that'll clarify that for anyone who has this puzzle. Anyway, there you have it, GR Cubed. Thanks for the literally, not just hours, but days, weeks, even months of entertainment getting all this figured out. So next we have to decide what else we're going to look at, what else we're going to demonstrate. Could it be this, which is worth going through, or could it be, oh I don't know, something else? Thanks for watching.